Hello, dear listener. This is M. Solomon Enterprise. Today, you will learn about panel wiring of single-phase forward and reverse circuit and its operation. So, the circuit that I'll draw right now is the main circuit of single-phase forward and reverse circuit. Right. From there, I drew the sketch of a single-phase forward and reverse circuit for main circuit. All right. So from the main circuit, because of its single phase, which means the supply will come with live and neutral, and also earth, and then earth will be connected straight to the motor. So when it's connected straight to the motor, either you can connect it to the bolts or casing points. Yeah. So that's where you connect your earth. Right, we have a supply there, 3 wires, we are happy. And live and neutral will go to the endpoints of the double pole circuit breaker. Remember, we've learned about 3-pole circuit breaker. Now we have the double pole circuit breaker, which means from the left side will be live and right side will be neutral. So I'll start with my neutral first. My neutral out point will go straight to the neutral bar and wait for all the neutrals. And then I'll come to my live. My output of live in the double pole circuit breaker will go straight down to the in point of the contactor of forward. Why I say this is contactor of forward, this is the contactor of reverse, because right now we are dealing with single phase forward and reverse circuit. We have to indicate which circuit it is for forward and which circuit is for reverse. Right, so my live went to the in point of contactor of forward in live 1, and from live 2, if you can check, this connection is our neutral, and then live 3, it is bridged to the first wire, which it went to the third point, which is live 3 of contactor forward. So what we did in the endpoints of forward will also do in the endpoints of reverse. So my live 1 is this one, and my live 1, it went to live 1, and then live 2 is neutral, and live 2 is neutral. Live 3, it was bridged from live 1, live 3, it was bridged from live 1. So the endpoints are the same, but let's check from the out points. I'll start with the out points of forward contactor. So the out point from live 1 will go to the endpoint of the running winding. So these are my windings. Will go to the endpoint of the running winding, and the out point of the running winding will go to the out point of live 2, which is my neutral. So you get it? And then I'm done with these 2 points. Now I'm going to this third point. So this third point is live 3 out of contactor forward. It will go down to endpoint of starting winding, and then my output of starting winding will go to the starting capacitor and also bridges to the running capacitor. From the starting capacitor, its life will go to the in of the centrifugal switch, and then the out will go to the neutral. The out of the centrifugal switch will go to the neutral, and then my out of the running capacitor will also go to the neutral. So I'm done with the connection of the motor. Now let me check my outputs of contactor of the reverse. So my live will be bridged with live 1. Live 2 will be bridged with live 3 in the contactor forward, and then live 3 will be bridged with live 2. Why I switched live 2 and live 3? is because of in the forward direction, everything is connected the way it is, but in the reverse direction, two wires in the output of the contactor must be switched. Either I can switch 1 and 2, or 1 and 3, or 2 and 3, or 3 and 1, either way. So I chose to switch 2 and 3, live 2 and live 3. So that is our parallel wiring for single phase forward and reverse circuit. And then where you see the green dotted lines that I've made a rectangle box. So these green dotted lines, it indicates that this is a single phase motor. So inside the connection of single phase motor, there is this connection. So yeah, I'm done with the main circuit of single phase forward and reverse, and I'll show you the single phase forward and reverse, the control circuit. Right, I'll draw it right now. Right, now there is my sketch of a control circuit of single phase forward and reverse. So if you can check the connection from this part until here all the way upwards, but not looking at the connection at the bottom here, this is a direct online circuit, but it only changed here because of I've inserted the interlock of reverse. Right now I'll show you how to operate the circuit, the control circuit of single phase forward and reverse. Right, my live 1 will come from here and goes down to the in point of 1M circuit breaker. So right now you know where I bridged my live 1, and then my output will go to the close contact of overload relay, and then which means current will flow all the way down to in point of emergency stop, and it is close contact, which means current will flow, and then the out point will go to the in point of stop button, and it finds that it is a close contact, and then current will flow, and then the out point will go to the in of the start and waits there because of it is open contact, and also reaches down to the retainer contact of forward, which is open. Current will be stuck here. Again, current comes from this side and goes up and waits here in the start button of reverse in the in point, and waits here because we have open contact. Another way, current comes here and stops here because we have open retainer of reverse. Right. When I switch off my circuit breaker, which means current from this light will go down right now because it will down. But if you can check from the neutral, we have also neutral, which will go to the neutral bar and all the way to my two coils, the coil of forward and the coil of reverse. So from my live side, when I turn on the circuit breaker, current will flow down here and finds close contact, which will flow down, find close contact, goes down, find close contact, goes down, find open contact, goes here, open, goes here, open, open, which means right now the circuit is waiting for me to push one of the start button. Remember, forward and reverse, your wheel cannot go clockwise and anti-clockwise at the same time. So we will prove it with the control panel that you cannot start at the reverse direction and the forward direction at the same time. Right. When I push the start button, which means it will create a close contact, current will flow here and finds interlock of reverse. So I'll show you where you find the interlocks. So it finds the interlock of reverse closed, which means current will flow all the way to a coil of forward. So right now coil of forward has live, and from the neutral side it also has neutral, which means right now coil F is on. Coil of forward is on, and when it's energized it will affect its contacts and interlocks, which means this contact will be closed and this contact will be open because of the interlock of forward. So when the coil of forward is energized, it affects all the contacts of forward, which is the retainer of forward and the interlock of forward. So right here is closed and right here is open. So right now I'm letting go of the start button, but when I'm letting go of the start button, the coil of forward will keep on being energized because of right now my life has retained with the contact of forward and goes up here all the way to the coil of forward. So let's see if we can start the coil of reverse. So my current, remember, it came here, stuck here and here. Right now it's waiting for me to push the start button. When I push the start button, it's creating a close contact, which means right now my current will flow here and finds open contact, which means it will stuck here and it will not energize reverse coil, which our statement is right because of we cannot energize forward coil and reverse coil at the same time. My wheel cannot move in both directions at the same time. So right now my wheel is moving forward but not in reverse direction. So for your wheel to move in the reverse direction, you have to press the stop button or the immediate stop or the stop button in the overload relay. Remember the one that I showed you? And when I press the stop button here, remember I've let go of my start button, which means right now it's open. So when I let go, I press one of the stop buttons, either immediate stop or stop button or stop button from the overload relay. Now coil F will be off, and then the retainer, the contact of the retainer F will be open, and then right now the interlock of F will be closed. We good? And remember here, when I let go, it will be open. Yes. So right now, I pressed the stop button and my sketch went back to normal before anything was energized. Right now, since when my current has stopped here and here, here and here, I started forward, it has started, and it didn't let me to start the reverse. So let's see when I start reverse what will happen. I press the start button of reverse, which means it will create a close contact, which means right now when we have close contact, current will flow and finds a closed interlock of forward, which means it will go straight to the coil. Right now my coil has live, but from the neutral side it also has neutral, which means right now coil of reverse is on. Yes, it's on, and when the coil of reverse is on, it will affect all its contacts, which is the retainer of reverse, it will be closed, and the interlock of reverse will be open. And when I let go of the start button of reverse, when I let go of the start button, coil of the reverse will be energized because the life will be retained with the contact of the retainer of reverse. It will be retained all the way to a coil of reverse. So right now, let's see if I can start my my forward. If current is trapped here, I press my start button, it creates close contact, and when it gets here, it finds open interlock R for reverse, which means my current will be stuck here, which means this guy won't get live but only neutral, and he'll coil of forward will remain de-energized. So it will only be energized when we stop reverse. So that's how your forward and reverse circuit operates in the control circuit. So remember, right now we must get our voltage that is drawn in the circuit, and your voltage, it will need a voltmeter which you'll connect its wires under the circuit breaker and under the neutral bar, which is here. I'll take it from my life. I'll put V for volts to show that this is a voltmeter. I'll connect it in my neutral. Remember, when you get the reading of a single phase, it must be live and neutral. So it will be 220 volts to 240 volts. So yep, that's how it is. That's how you operate. That's how you wire your panel of single phase forward and reverse and operate it. So thank you very much for watching. Remember to follow, like and subscribe to YouTube and TikTok channel. And the channel name is @MainMade1983. Thank you. Goodbye.